Today we're going to talk a little bit about pH. I'm sure you've all heard of pH and you have ideas of what that probably means. Today hopefully we'll have a little bit better understanding of it. It's a very brief introduction. If you continue on in any kind of a science in anatomy next year, in AP Bio, in AP Chemistry, or later in your life, you're going to go into a lot more detail about this, but it'll be a good primer and starting point for you, okay? So up on top here, with your notes, we have what we call a pH scale. And a pH scale ranges from 0 to 14. And it's very important that you understand what these numbers signify, okay? We'll learn about the equations later on, but first let's just talk about what the scale actually signifies with the numbers. So what you have on top is you have the range from 0 to 14, which starts with being zero is acidic. Okay. 14 over here is what they say alkaline, or you could say basic. So in the middle, you say that that is neutral. Okay, so it goes from basic at 14, acidic 0, neutral 7. Below, A through M, what I have are some different very common compounds, substances that we can relate to the pH scale. If you're looking at that, I'm sure you could probably eye up a few of these. Now, what is the most acidic? Maybe you don't know what basic is, but we usually know more about what acidic means. So by looking at this, could you organize this? Okay, on your worksheet you're going to have to do this, and on your test you're going to have to be able to place some of these things in accordance to the pH scale. Okay, so I guess we'll just start. Let's talk about the main points here. 0, 7, 14. So what is neutral on here? Let me give you a rundown of our usual suspects. From A to M, I have liquid Drano, I have bottled water, I have a cup of coffee. Letter D is stomach acid. I have a bottle of Pepsi, so basically a cola. I have salt water. I have Barq's root beer. I have a battery, so we'll talk about battery acid. Cleaning solvents like Lysol and other things that you would use in your bath or your kitchen. Blood, acid rain, baking soda, and sun drop. So, what is neutral? Hopefully we all would know that. That would be water, right? Water is neutral. We talked about that on Friday. It has H and OH, so that works out really well. What is the most acidic thing on here? That will be, so you're thinking about it, battery acid. Battery acid is the most acidic. What is the most basic on here? You need to know this. Things that are really basic can dissolve fats and oils and grease. So things in the bath or in cleaning solvents are usually the most basic. So something like liquid Drano, which is used to dissolve clogs that could be either, again, fats and oils or clogs of hair. It's supposed to actually dissolve those clogs. So that would be the most basic. So that is the good starting point. Okay? Let's go a little more. What else is really, really acidic? You almost all know. Throw up, you feel it. If you have heartburn, it's the acid that's sitting up in your throat. That's stomach acid. That's number 1. Okay. What else is really basic? Other cleaning solvents, but we're going to go at about 12. Okay. All right. So now we got to fill in the rest. Let's start from the right side here. Baking soda is around 10. Whenever you spill an acid, you need to put baking soda in some water, and usually that will help neutralize it. Let's talk about some acidic things. Okay, so now These aren't exactly these whole numbers, but the most acidic kinds of sodas are colas. It's a little bit above 2. I'll show a link in a moment. It's Pepsi. Okay, then we have our Sundrop. Then we're going to have our Barq's Root Beer. Then we're going to have our cup of coffee. I know some of you were hoping for this, but acid rain's not until about there. When there's acid rain, it's not dissolving people as they're running from the streets, but acid rain is bad for buildings and things over a long period of time. It will slowly erode a limestone and things like that. Seawater is around 8, and then blood is between 7 and 8. So there is your pH range. If you take a look, the reason why something is acidic or basic, on the left side you have more H+. You need to know this. And on the right side you have more OH-. So we think about concentration of H+. This means the concentration or the molarity of H+, that associates with more acidic solutions. If you have concentration of OH-, that deals with more basic or more alkaline. So here's a list of different kinds of drinks, and I think this is very interesting. And hopefully you can see this. Tooth enamel dissolves at 5.5 pH. What I want you to understand right now is that we're going to learn equations in a second, that each number, it's based off of log. So logs are based off of tens. So each of these are 10 times greater than the next, or less, okay? Meaning this, if this is 10 times greater here, okay, so Pepsi's 10 times more acidic than Sundrop, that means 1, 2, 10, 10. This is 100 times more acidic than root beer. So, if you are drinking coffee versus Pepsi, this is 1,000 times more acidic or less acidic. And that's where it becomes an issue. Okay, tooth enamel dissolves right around here. So anything lower than that will slowly dissolve the enamel of your teeth, and you cannot get it back. So if you want to take a look at your favorite drinks, I think this is really interesting. Look at who's the winner. RC Cola. RC Cola, in theory, is less than 100 times less acidic than battery acid. Think about that. So you can go through it. Milk's way up here. You got Sprites and Mountain Dews, 3.22. Gatorade. Right, Coke. Again, teeth enamel's way up here, 5.5, somewhere in there. All right, let's talk about a couple equations here. So, you will be provided these. These are not required to memorize. And can you apply these equations to the values that you're given? You should be able to handle something like that. Okay, so you've all heard of pH, and the range of this is called, or on the pH scale is 0 to 14. So we're going to start with the first equation. It's pH plus something I'm about to talk about. POH equals 14. No one talks about this thing called POH, but pH is about H plus, POH is about OH minus. So you add them all up, and the balance between them, if you see right in this table here itself, you have H plus and OH minus. There's different amounts. Hey, I have more H plus here and less OH minus. Here I have more OH and less H plus, but they all relate. They all relate to each other. So how that relates is actually this equation. If you knew the concentrations, it could equal that. Reminder again, any bracket that you see, brackets mean molarity, which means a concentration. Okay, so the big equations that we're going to utilize are these. When you want to find a pH, as I said, it's based off of log. So it'll be negative log of H plus. If you want to go the opposite way, by the way, you need concentration. It's 10 to the negative pH. It's just flipping it. And then the same equation is true for pOH. So these are my equations that I need to not memorize, just be able to apply. I think we'll do fine on that. Let me show you a couple examples. One final thing, just in case this comes up. That H plus also equals H3O plus. They're the same thing. If you ever see that. So if you do get confused, that's definitely something that will help you. Okay? All right. So you should have a calculator out. You'll want to know how to do this. Because you are given the equations, this should not be a huge issue. But if you don't know how to do it with your calculator, then you're in trouble. So let's take a look at an example. It says, what is the pH of a 0.005 molar HCl solution? Okay, what? Right here, notice HCl has an H. This is an acid. So this right here, better worded, you might want to write this down for yourself. That's what that means. I am telling you that the concentration of H plus is 0.005. So all we need to do is look at which equation would be using these two things. I want pH, I have concentration of H plus. So I look up top, which one would it be? Oh, it's right there. Oops, sorry. So I need pH equals negative log of H plus. So I just plug it in. Negative log of that. Please try to do this on your calculator. With pH, we try to write 2 digits past the decimal place if possible. So that's a pH of 2.3, which is about RC Cola, actually. Okay? Take a look at the next one. And if this is going too fast, we can just pause the video. All right, what is the pH of a 0.00036 molar NaOH solution? Okay, what do you think this is? Well, let's talk about what we see here. This right here, because of OH, Arrhenius definitions of acids, H plus is an acid, OH is a base. So this is a base. So again, then what does this mean? This is concentration of OH minus. Okay, here's the problem. OH does not deal with pH. If you look, if I want concentration of OH, it solves for POH. So whenever you have a base, it's going to take 2 steps. And I will explain as I show you this, but this is the equation you want. Okay, so let's start here and then I'll go into that further. So I get that. That is not my answer. No one cares about POH. I need pH. So I have POH, I need pH. So what equation do I need? I hope you see it. I simply need that. So you're going to take 14 subtracted by that. Okay, because this is basic, because you're dealing with a base, it should be greater than 7. Okay? Again, neutral's here. So anything on this side is acidic. Anything on this side is basic. So if it's greater than 7, it better be basic. I'm dealing with a base, so this makes more sense. This is lower. This is lower than 7, so this is acidic, right? This is greater than 7, so this is basic. So our last one. What is the OH concentration of a solution of HNO3 that has a pH of 2.75? Woo! Okay, what does that all mean? Okay, what is that? That's an acid. Okay? What is an acid? An acid has concentrations of H+. And I was given a pH. So let's look at that first. What equation do I need that has H+ and pH in it? This one. This is the hardest problem on here. So this is what I need. Okay, so I take 10 to the negative 2.75. Please make sure you try this on your calculator. This is the hard one. It's second in log, and negative 2.75. You're going to get a small number. That's H+. Okay, what do I do with that? Well, I have H+, and I need OH-. So what equation has H+ and OH- in it? That one. So I could do it like this. That's one way. What I like about pH problems and acid-base problems, there's always two ways to do this. The long and short of this is, guys, you have to either be in base context or in an acidic context. So if you see pH and you see OH-, those are opposites. So the other thing you could do is you could do it this way. This is just a different way. What if I get it into POH? So I take 14 minus 2.75, because this is pH. Okay, what if I do it that way? Why am I doing it like that? Because I could get the context into POH. So then I have that. Why do you do it like that? Because there's an equation that's just simply this. And that's maybe more direct, if you like that idea. Oh, okay, yeah. I can just do this and put it by the POH. If I take that, second log, negative 11.25, I get exactly the same answer. So, that's where we're heading. That's what we're working on. That is the last of our new material. So these are all the equations that we're going to be utilizing. And you don't have to have any of them memorized. Can you apply them? Okay? And I will actually scroll back down on that last problem for you. Okay, we're going to watch one more interesting video about how pH and acidity affects our bodies. It's amazing. Drinking diet soda and other things, how it affects and how our body has to regulate itself to fix the leaching of vital minerals and ions that we have in our body. Okay, so I hope you really do enjoy this one.